In this question, we are asked to solve for x. There's a strategy that I need to show you. Always convert the exponential fraction to a root. The denominator is your root, so the denominator is 3. It means we have a cube root. And then the numerator is the power. So in this case, our power is 1, so it's to the power 1, of which we don't show, and equals to 3. Right? So basically here we just have cube root of x equals to 3 because the power is 1. And when the power is 1, we don't have to show it. Now, how do we remove a cube root? We remove a cube root by cubing both sides. So we cube both sides to remove the cube root. And then on the left, we have x. On the right, we have 27. And that is it for question 1. Let's go to 2. On question 2, we have x to the power 5 over 3 equals to 32. We need to convert to a root. The root is 3. Remember, we said the denominator is your root. So we have a cube root of x all to the power of 5. The numerator is your power. So the power is 5. And then we have 32. How do we remove the power? We remove the power by rooting. So we are going to root 5 times on both sides. So we're going to fifth root 5 on both sides to remove the power of 5. And then we are now left with cube root of x on the left. And we know that fifth root of 32 will give us 2. The fifth root of 32 is 2. Now we need to remove a cube. To cancel a cube, we need to cube both sides. So we cube both sides to cancel the cube. On the left, we left with x. On the right, we left with 8. And that is our answer for number 2. Let's go to 3. We have x to the power 3 over 2 is equals to 8. We need to convert to a root. The root is 2, which means square root. I can show it. It's a square root of 2. And then all to the power of 3. Remember, the numerator is the power, which is 3, equals to 8. We firstly remove the power by cube rooting it. So we're going to cube root both sides because our power is 3. So we cube root. We just do the opposite of the power. And then on the left, we left with 2 square root x is equals to cube root of 8, we know is 2. To remove a square root, we need to square both sides. Then x equals to 4. All right. Let's go to question 4. We have x to the power 2 over 5 is equals to 4. We firstly convert to a root. The root is 5 because the denominator is 5. So we have fifth root of x all to the power of 2. The numerator is 2, so is the power, is equals to 4. We need to square root to remove the power of 2. So we square root both sides. Square root both sides. You don't have to show the 2 on the square root. You can just write square root. But even if you show it, there's nothing wrong. And then we left with fifth root of x is equals to what? 2. Ne? But remember, because we're square rooting, we need to always show plus minus. When you are rooting with an even number, you will have to show a plus minus. Okay, so if we square root, fourth root, sixth root, we show a plus minus. The reason why on the other ones I didn't show a plus minus is because this was an odd number when I was rooting. This was an odd number. Here I didn't root. So if you root with an odd number, you don't show plus minus. But if you root with an even number, you must show plus minus. So the answer will be plus minus 2. So we have fifth root of x equals to 2, or fifth root of x equals to negative 2. And then we're going to put to the power 5 both sides to remove the fifth root. And then we have x equals to 32. Or x equals to negative 32. Negative 32, sorry. Okay. And then let's go to question 5. Number 5. We have x to the power 2 over 7 equals to negative 1. We convert to a root. The root is 7 because it's the denominator of x, and the power is 2 equals to minus 1. So obviously we need to remove the power of 2. We need to square root both sides. We need to square root both sides. And then we put plus minus because it's an even number. And we can see that square rooting and negative is not possible. Therefore, this one we're going to say no real solution. No real solution, because an even root cannot be negative. We cannot have a negative even root or an even root of a negative number. Okay, so if you try to press that on your calculator, it's going to give you math error because the solutions are non-real. All right, let's go on to question 6. Number 6, we have x to the power 5 over 4 is equals to negative 32. The root is 4 because it's the denominator, and the power is 5. And then we have negative 32. To remove the power of 5, we need to fifth root both sides. And then because we are rooting by an odd number, no need for plus minus. The fifth root of negative 32 is negative 2. And then this side we're left with 4 square root x, because the fifth root and the power of 5 cancels. Now we need to put both sides to the power of 4 to cancel the fourth root. Put both sides to the power of 4 to cancel that. No? But now let's analyze this actually, ladies and gents. I just want to go back here. Can this be true? We have an even root equaling to a negative number. Remember, this number here cannot be negative, right? The principal even root of a real number cannot be negative. So the output, this side, no matter what x value is, cannot be negative. So that's not true. Therefore, we're going to have no solution. An even root cannot output a negative. Right? It's an odd root that can output a negative, but an even root cannot output a negative. Excuse me. Let's go to question 7. Question 7. We have 3x to the power 3 over 5 is equals to negative 24. Let's see, ladies and gents. First, we need to isolate x by dividing both sides by 3. So on the left, we're left with x to the power 3 over 5 equals to negative 8. We get negative 8 by dividing negative 24 by 3. So we're going to basically divide by 3 both sides. Okay, now we convert to a root. The root is 5. The root is 5. And the power is 3 equals to a negative. Okay, now we're going to cube root both sides to remove the power of 3. And when we cube root, we don't put plus minus because it's an odd number. On the left, we're left with fifth root of x. Cube root of negative 8 is negative 2. Now we raise both sides to the power of 5. Raise both sides to the power of 5. And then we're going to have x is equals to negative 32. Let's go to question 8. On question 8, we have 40. This is 8, ne? We have 40x to the power of negative 3 over 4 is equals to 5. All right. So, ladies and gents, I'm firstly going to do this. Ne? I want my power to be a positive. So this is what I'm going to do. I'm going to say 40 over x to the power 3 over 4. If it was on the numerator, you take it to the denominator to change the sign on the exponent. Is equals to 5. Then this is 5 over 1. I can cross multiply. I'm going to have 40 equals to 5x3 over 4 as the exponent. Then we're going to divide both sides by 5. Then you can see I'm going to have 8 is equals to x3 over 4. Actually, let's write it this way. Now I have x to the power 3 over 4 equals to 8. So my root is 4 and my power is 3. Remember, the root is the denominator, the power is the numerator. Okay, and we get 8. To remove the cube, we must cube root both sides. Okay, and then we're left with 4 square root x is equals to 2. And then we need to put everything to the power of 4. Then x is equals to 16. Let's go to question 9. On question 9, we have 2x to the power 6 over 5 equals to negative 2. We are going to divide both sides by 2 to isolate the x. So we're left with x to the power 6 over 5 equals to negative 1. Let's now convert to the power and root. The root is 5 and the power is 6 equals to negative 1. Now let's take the root of negative of 6. This side is negative 1. So obviously to remove the power of 6, we take a root of 6. But taking a root of 6, we must put a plus minus there. Why? Because in a root of even number, we always put plus minus. But this cannot be real. We cannot have a negative index of an even number root. The root is an even number. We cannot have a negative inside. Okay? So a square root of a negative number is not possible. A fourth root of a negative number is not possible. A sixth root of a negative number is not possible. An eighth root of a negative number is not possible. A 10th root of a negative number is not possible. So in simple terms, what I mean is, as long as you have an even number here, inside you must have a positive, not a negative. So here we're going to say no real solutions. No real solution. So the solution is non-real, it's imaginary. Okay, let's go to 10. On 10, we have negative 16 x to the power of negative 3 over, to the power of negative 2 over 3 plus 4 equals to 0. Yeah? So what I'm going to do is I'm going to make this term positive by transposing it to the right. So on the left, I'm left with 4 is equals to 16x to the power negative 2 over 3. So now I need my exponential part to be positive. I'm going to have 4 is equals to 16 over x to the power 2 over 3. You see, it was on the numerator. I take it to the denominator so that the sign of the exponent can change. Then 4 is over 1. I can cross multiply. I have 4x to the power 2 over 3 equals to 16. Then I divide both sides by 4. Divide both sides by 4. Then I'm going to have x to the power 2 over 3 equals to 4. And then we can see now we need to convert to we need to convert to a root. The root is 3. The power is 2. Remember, the root is the denominator. The power is the numerator, which is equals to 4. We remove the power by a root, so I have to square root both sides. And when I square root, I must put plus minus. So I'm going to have cube root of x is equals to plus minus square root of 4 is 2. So there I have two answers. The first one is cube root of x equals to positive 2, or cube root of x equals to negative 2. And then to remove a cube, I must cube both sides. To remove a cube root, I must cube both sides. Okay? Then x will be equals to 8, or x equals to negative 8. And that marks the end of this video, ladies and gentlemen. Thank you very much. If you found this video helpful, please share with family and friends, and don't forget to subscribe. Let's make the Say Guru army grow. You are part of the family. Thank you very much if you got up to this far. Tango.